Hello everyone, welcome back to our channel. Thank you for staying tuned. Alright, so today we are supposed to show that 3 to the power of n plus 3 to the power of n plus 1 plus 3 to the power of n plus 2 is divisible by 13. And if this is true, we're going to see that the answer from this sum is in multiple of 13. Yeah, because 13, since it's divisible, should be divisible by the sum. That means 13 is a factor of the answer that we should get. All right, so we are going to say solution and 3 to the power of n plus 3 to the power of n plus 1 plus 3 to the power of n plus 2. All right. If you remember, we are going to say that the law of integers say if a raised to power n times a raised to power 3 is equal to a n plus 3. I need to say it will come in any form. Maybe this form will go back here or this here will come here. Unfortunately for us, we're having it here, so we're trying to bring it back to this form. What do I mean? We are going to write as this 3 raised to power n with a bracket, this is a plus, and here will be 3 raised to power n times 3 raised to power 1. You can see this, close the bracket plus, open again, 3 raised to power n times 3 raised to power 2. And this is fine. Alright, why do we do this? We want to bring out 3 raised to power n from each of the terms. So after bringing that out, what will become of our equation? We see by saying 3 raised to power n. We take 3 raised to power n from here to be left with 1. And this is the plus from 3 raised to power 1 plus it becomes 3 raised to power 2. Yes. And this is 3 raised to power n. 1 plus 3 plus 3 times 3 is 9. You see this? We are going. And 3 raised to power n, 9 plus 3 plus 1, this is 13. Our answer is 3 raised to power n times 13. If you see, the answer speaks of what we talked about from the beginning. If you divide this by 13, your answer that you will get will be 3 raised to power n. So 13 is a factor of the sum eventually. But also to further prove this, we can see that from the equation given, 3 raised to power n plus 3 raised to power n plus 1 plus 3 raised to power n plus 2. From the question given, this is the typical geometric progression. What do I mean? If the first term is 3 raised to power n, if we want to multiply the first term by 3, what will become of it? It will be 3 raised to power n times 3, which is equal to 3 raised to power, and remember 3 raised to power 1, n plus 1. And this is the second term, first term, second term, and if the third term definitely will be 3 raised to power n times 3, 1 times 3 again 1, which is equal to 3 raised to power n plus 1 plus 1, which ends up with 3 raised to power n plus 2. With this, it's therefore obvious to us that the common ratio R will be 3. And the sum of a GP is given as R and is equal to A into R raised to power n minus 1 all over R minus 1, provided R is greater than 1. And our A, our first step is 3 raised to power n. Our R is 3. Yeah. And our n is 3, the n term. So if we have this, each of them represented, we can fix them in the equation to see how it looks like. becomes S3 is equal to A will be 3 raised to power n, and arrow of course is 3 raised to power, and n is 3 minus 1 all over 3 minus 1. And this is 3 raised to power n. 3 raised to power 3 is 27, minus 1 is 26. All over 3 minus 1 is 2. This is multiplication. Okay, deal with 3 raised to power n times 26 all over 2. Yes. So how, okay, we can cancel 2 into 2, 1, 2 into 1, 1, 2 into 6, we have 3. Eventually, our answer becomes 3 raised to power n times 13. The answer we got previously using the first method. That is to say, 3 raised to power n plus 3 raised to power n plus 1 plus 3 raised to power n plus 3 is actually a multiple of 13, and 13 is a factor of the sum. Thank you for staying tuned. Bye bye.